Hello, in this demo we're going to see how to protect sensitive information in your Kubernetes cluster using CipherTrust transparent encryption for Kubernetes. So what is CipherTrust transparent encryption for Kubernetes? CTE for Kates is a scalable data at rest encryption solution that's implemented as a common storage interface driver, so will fit right into any Kubernetes architecture. CTE for Kates is supported on both the free-to-use Community Edition of the CipherTrust Data Security Platform, as well as the Enterprise Edition. Let's take a brief look at the CTE for Kubernetes architecture. CTE for Kates is deployed into the Kubernetes cluster using a simple deployment shell script, which is available via our GitHub page. A storage class is defined that tells the CTE for Kates implementation how to connect to the CipherTrust manager for client registration and key management. When we deploy an application that may have sensitive data that's going to be stored on persistent volumes outside the lifetime of their containers, we can define a claim that points to a volume protected by the CTE storage class. The CTE claim is a combination of a persistent volume claim, pointing at the persistent storage that we wish to protect, the storage class that defines how we connect to the CipherTrust platform itself, and a reference to the CTE policy, which tells us which encryption keys and any additional access control we wish to provide within that protected guard point. Once an application is started with a claim to a CTE protected volume, a staging pod is created for each of the persistent volumes that will be protected. This coordinates with the CTE for Kates daemon running within Kubernetes to register the application containers in pod and apply the appropriate protection policy to the volume, which is then mounted to containers within that pod. The CTE for Kubernetes deployment script is publicly available on the Talus CPL GitHub page. Here we can see there's documentation for downloading and deploying the script. The first step is to clone a copy of the deployment script from the Talus GitHub page. Once cloned down to your system, you should have a CTE CSI deploy folder. And in this directory, you can see that we have a deployment shell script. We can then run the deployment shell script, providing a user ID and password for our Kubernetes cluster to pull the images. You can see we very quickly have deployed to our cluster. And now I'm going to switch over to my cluster administration utility and see the deployment. So I've switched over into my cluster administration utility. Here I'm using the K9s utility. You obviously can use kube control or any other utility out there to administer your Kubernetes cluster. But in this case, it just makes it a little bit easier to demo and show what we're looking at. So here I have a 3-node cluster already up and running. If I take a look at my deployments, I can see that the deployment script did deploy a deployment called CTE CSI controller, and it's deployed into the kube system namespace, since this will be running as a service within the cluster. If I take a look at the pods that were started as part of that deployment, you can see that I've got my CTE controller pod. And for each of my physical nodes in my cluster, I also have a CTE node, a pod running on each of those as well. Also, for the purpose of this demonstration, I do have a NFS share that I've exposed as a persistent volume. And this is going to contain sensitive information from our containerized application. So I want to protect this NFS share and encrypt all of the data that is written to it. If I look at my persistent volume claims, I have a claim that also references that NFS mount, as well as a CTE claim. And this CTE claim is what identifies the protection policy from the CipherTrust manager that will be applied, and what storage resource we wish to protect with that policy. This claim is going to be used by our sample application to then mount an encrypted volume. One final piece of configuration that we need to look at is in the CipherTrust Manager web console. I'm in the CipherTrust Manager right now, and if I go to my transparent encryption service tile here, you can see that we have Kate's clients as well as Kate's storage groups. And we'll need to create a storage group to associate the storage class that we'll be using within the Kubernetes cluster, and also what namespace we'll be operating in. This storage group is then assigned a CTE policy. In this case, I have a very simple policy. In this case, it only has one rule, which is allow all operations, permit them, record them, and apply the encryption key on behalf of the requester. We can get much more complicated later on by adding additional security rules to lock down individual users and processes from accessing files within the persistent volume. Now let's take a look at the sample application that we're going to secure with CTE for Kubernetes. I have a deployment definition file here, and if I take a look at the details, we can see this deployment is called demo app. It's going to start up 2 replicas, so there's going to be a pod on each of 2 nodes, leaving our 3rd node free to scale up. And if you take a look at the volumes that are defined, we've created a volume called CTE volume, and this references our CTE claim. This is what's going to connect this application to the secure guard point created by CTE. This is all going to get mounted within this container on the path/data. This demo app is very rudimentary. It is a simple Ubuntu Linux container instance, but it will allow us to go in and see the data protection in practice. So I'm going to go ahead and apply this file. And if I go in and take a look at my pods, I can see that in the default namespace, we have 2 staging pods that are started up for CTE, 1 for each node, and then the demo app has been deployed. Now that my pods are running, I can connect in and validate that we're able to create secure files. So I'm going to connect to this first pod running on node number 2. And remember, we attach the data directory, the data volume, via a CTE claim. So if I create a file, and then cat that file out, I can see that the file looks completely normal. I can see the clear text. And if I go into the other node, we can verify that we get the same behavior from other pods running this application. But what we don't want is we don't want someone who is unauthorized to access this data, either within the container itself, or in this case from external. If I mount this directory that contains the persistent volume and try to view those files, so I can see the file that was just created from within the pod, but if I try and view the contents of that file is encrypted. So that data is only accessible to the pods with the appropriate claim running within the Kubernetes cluster. Now that we've successfully deployed our demo app and secured the persistent volume with CTE for Kubernetes, let's scale up the deployment and ensure that any dynamically added pods also inherit the same encryption controls. So I'm going to change the number of replicas to 3. And if I take a look at my pods, I can see there's a new application starting. The new staging pod has also started. And then the file system's able to mount on our demo application. So now I'm going to connect to this new pod and verify that I can still see the secret data, which I can. Now that we've successfully deployed our application onto Kubernetes and are protecting the persistent volumes with CipherTrust transparent encryption, let's take a look at the CipherTrust web console and see what information is being provided. If I go into the transparent encryption service tile, I want to see my Kubernetes clients. And we can see here that each of the running pods has been automatically registered without any intervention on our part. Can expand out this information and see the node that the pod is running on, the storage class that it's associated with, the namespace it's running in, as well as the CTE logging profile that is associated with these instances. If I click into the particular client name, I can see also which policies have been assigned to that container and validate the persistent volume claims that are being protected. To recap what we learned today, we saw how to use CipherTrust transparent encryption for Kubernetes to secure persistent volume data in our Kubernetes clusters.